Okay. Last class, we started the new concept. It's about decision tree. So decision tree is again a method for classification. So decision tree is basically is used to classify the instances by sorting all the instances, sorting them in down the tree from the root to some leaf node, and this provides the classification of the instance. And an instance is classified by starting at the root node of the tree. So this is the basic concept of the decision tree. Here, this is an example of a data set showing how the decision tree could be formed and how you can classify um, the data set based on various criterias, and different criterias are the student's age based on the column, that is student age, if it's less than equals to 30, within 31 to 40, or greater than 40. So based on this, how you constructed this tree, we are going to just learn about how to um, basically get this format of a tree from the data set and how it will help us performing the classification. So in there, mm, we have also seen the various test conditions for the nominal attributes, then the ordinal attributes. How do we perform the split based on multi-way or binary split, as well as in case of continuous attributes too. So while creating decision trees, we need to emphasize on what are the different attributes being used inside the dataset, and what are the different ways in which they can be split correctly. Then after that, we have seen some of the attribute selection measure. So here we have seen that a decision tree algorithm, which has been discovered by a machine learning researcher, and he actually gave the algorithm, which is also called ID3, or iterative dichotomizer. And after that, he made certain changes to the algorithm ID3, and it was famously known as C4.5, which is considered as the successor of the ID3. And this C4.5 is actually based on a greedy approach. Then there are certain things that we need to pay attention here. So various different measures are used while constructing the decision tree for selecting the attributes effectively. So those are the three things that we need to emphasize on. These are entropy, that is the expected information needed to perform the classification in a particular row or tuple in a data set, and this is the formula for it. Then what is the total information needed during the splitting condition or criteria? This is the next formula. And here in the information, actually we use the information, expected information, or the entropy as an input. Then lastly, the information gained. So finally we need to stop at the gain, that is information gain, and here we need to make a decision about the classification. And information gain is basically the expected information entropy minus the total whole information needed after the splitting criteria. So these are the three things. And then just starting with the ID3. Okay. So before understanding ID3, we must be clear about the entropy. And as entropy in the layman terms, it is considered as a measure of disorder. So if you can quantify what is the disorder, or how much misclassification is there in a given data set that you want to classify properly, then from there, from the measure of disorder, you can have proper knowledge about what different measures could be taken to have a proper classification. And in a given data set, Suppose in a data set there are various classes, and for suppose there are n number of classes, so their proper probabilities can be p1, p2, p3 up to like this up to pn. Then the information conveyed, the whole information or entropy of the given data set P in terms of probability will be this formula. Negative of summation of each individual probability is considered in this way: P1 into log P1 plus P2 into log P2. So we are going to see this through an example here. Let's say in a given data set, the P1, P2, two probabilities are given. So how can you perform the total whole information, that is IP? It will be basically based on the formula. So I'm taking this one 0.5 and 0.5. So it will be negative of your 0.5 multiplied by your, based on the previous formula in the previous slide, log P1, that is log 0.5 plus again the next one is 0.5, so 0.5 multiplied by the same thing, log 0.5. First you will do the multiplication, add them, then take a negative of that. That is your IP, which is nothing but your defined entropy for this whole data set. So now if you consider 0.67, 0.633, then what you will do, you will basically, give me a moment. I'm just taking out the values to have proper values here. So for 0.67 first, P1 log P1, so we will have 0.67 and multiplied by log of 0.67. It depends on how many probabilities do you have in the given data set. Based on the attributes that you have, let's say there are only two attributes, then 0.33, 0.33, sorry, what am I doing? Should be before that. 0.33 and log of 0.33. This is how you calculate the entropy. In the same way, for 1, 0, you will have the entropy as 0. So how much amount of information is actually there based on the probability measure of various attributes in the given data set. Okay, so this is how entropy is calculated. Then we are going to basically try to understand these three equations that I was showing you to see how much is the total information gain. First we will calculate entropy, then information after splitting and considering the splitting, and then the information gain. So if we have all those three, how can we construct a decision tree? We will basically see an example. Okay, so let's see here. This is our given data set. Okay, so in our given data set, we want to classify our data set based on the binary classification, that is yes or no, and we want to classify based on this column or attribute, that is the insurance. So we want to determine if someone has a house, if has a house or don't have an house, or have a car or don't have an car, if have a child or not have a child. So depending on their yes or no values, what will be the final inference about insurance, whether that person will be likely buying an insurance or not, depending on the probabilities or information gain that will be received from house, car and child. So let's see that example. First, we need to find out what is the overall entropy of the given data set. So how do you infer that? For that, we need to consider this insurance attribute, and here you need to find out how many total instances are there. 4, 4, 8, total 8, and out of 8, how many are yes? 4 of them are yes and 4 of them are no. So here what we want to do, we want to basically find out the entropy as P log P, right? So first this one is for, as it is a binary classification, this one is for yes and this one is for no. Okay, so here total, this, if this is considered as half and this is considered as half, so you will take it as 0.5. Okay, if you just divide it, you will get 0.5, for this also 0.5 for yes and no. So that is why you have half P log P and P log P, that is half log half and half log half. This is the probability or the information or the entropy of the given data set. Now, after that, we want to find out what is the for a single house, single attribute or house. First we will look for house, then for car, and then for child. For the house attribute, what is the total information gain? So in order to find that, we need to find out the overall information of no and yes values of the attribute. Okay, then from there we will see what is the information about the given attribute. This is the formula for it, and then the information gain. You can refer to the slide where we have that formula. We are just basically applying that here in practical terms. In this given house attribute, out of total 8, how many are yes? 4. And how many of them are no? Again 4 by 8. Here first we are finding T of no, that is associated with only no value probabilities. Okay, here again for only no, this is 1, and here these are the things. So we will pay attention now to only this tuple and this tuple here. So please be careful how I'm trying to explain here. So first for T no, we are trying to find out the info or the entropy of T no. So out of total 4 no's, how many of the no is associated with yes and how many of them are associated with no? That is our logic to find out the entropy. So first we are trying to see how many of them are associated with no of the insurance from the house. So there is 100% probability, and depending upon how much proportion of the attribute values are associated with the given no, that will be out of total 4 no's, only 3 no's are associated with the no of the insurance. So that is why we have 3 divided by 4 here, P log P. Then this is from whichever is associated with no. Now we next have to see something which is not associated or associated with the yes value of no, just the reverse of it. So only one value out of 4 no's are associated with the yes value of the insurance. Okay, so that is why we have 1 by 4 log 1 by 4. When you calculate it, this is the given entropy calculated for the no info T no. In the same way, we will now find out for our given T of yes. So total how many yes? 3 and 1. It will be basically same thing. How many yes with yes of insurance? 3 by 4, 3 by 4. And how many yes with no? The reverse of that. That will be 1 by 4 log 1 by 4. And this is the info calculated. Now for overall attribute, that is house, when we try to find out the info or the entropy, it will be basically out of total 8 instances, how many no we have? We have 4. So 4 divided by 8 will be basically 1 by 2. That is why we have 1 by 2 info of T no. And then the yes, in the similar way, Okay, sorry, sorry. It was for your no. Okay, so for no, we have 1 by 2, and for yes also, we have 1 by 2. That is why this is how the info or the entropy of house in terms of overall whole info will be calculated. And this is what you have. Then the final gain will only be dependent on the overall info T subtracted by info of house T. When you have that, this is the value that we receive. So the information gain in the given data set in terms of this single attribute, that is house, we got 0.1887. In the same way, we will now find out the entropy about the car attribute. Okay, give me a moment. So for the car attribute, now we have to see how many, so what values we have, yes and no. So again, in 40, in the same way, how many 50% are yes, 50% and no. So we have the in 40 same as we had in the previous for the house. Then for car, we have yes and no as in this way. So how many no's? 6. And how many yes? 2. So out of 2 yeses, how many of them are associated with the yes? That is total full. Okay, so here the full will be considered as 1. And how many yeses of the car are associated with no? We have 0. So this will be 0 log 0. So this is the final value. Understood? If you have any questions, you can ask me. Then in the same way, we are trying to find out the T of no. So how many total no's are there? Total no's are 6. Okay. And out of total no's, how many no are associated with no? 4. So this will be actually 2 divided by 3. Okay, one moment. Yeah, 2 divided by 3. And out of how many no's out of the total 6 are associated with yes? That will be your 2 divided by 6, which will be 1 divided by 3. So this 1 divided by 3, 2 divided by 3 are placed here. Okay. So this is your value for info of T no. In a similar way, we find out the info of the car T in terms of T yes and info of T no. Basically having these two values placed here, and how much probability of T yes. We have total probability of T yes in the given data set is 0.5 or half for yes and no. Oh, sorry, I made a mistake. So info of car T, yes. So how many total yes are there in the given car attribute, not the insurance, okay? So for the car attribute, we have 2 divided by 8. That is why it will become 1 by 4. And out of 8, we have 6 no's. So it will be 6 divided by 8, which will give you 2 divided by 2 will be 3 by 4. That is why we have 3 by 4 here. Okay. Then we got the overall info or entropy of our attribute car. And then the gain of car T will be info T minus info car T. So here, this is what we have as the gain. So if you see here, the gain of the car T is higher than the house. Okay. So let's find in the next slide, we will find out in a similar way the entropy about the child. Okay, so let's just repeat the same thing. The overall entropy for the given data set, that is T. T will be 1, same here. And for attribute child, total no. How many no's? 4 no, sorry, 5 no's. Okay, five no's, and out of 5 no's, one is only associated with yes, 1 by 5, 1 by 5, and 4 no's are associated with no. Okay, in the similar way, how many of them are associated with yes? 3 of them. So total 3 are there, and total 100%, or all the 3 of them are associated with yes. So it will be 1 log 1 minus 0 log 0, because there are no probabilities of yes are associated with no of the insurance. That is why it will be considered as 0 here. So after you get that, in the similar way, find out info child t and gain child t. So info child t will be probability of t of yes. So out of total 8, how many, out of total 8, how many yes we have? We have total 3. So that is why info ts will be multiplied with 3 by t. And how many no's out of 8? We have 1, 2, 3, 4, 5. 5 no's. That is why we have 5 divided by 8 here for t no. In the same way, calculate, find out all the gains. Then finally, we found that the information gain of child tree is highest as compared to your house and car. So which is 0.5488. So now we will consider to form a decision tree starting with the child node as our root. After the root, as in the figure here, then we need to see if the child value associated is yes, the how many of them are yes and how many of them are no. 100% yes, 0% no. True, right? For 2, 3, 4 instance. Then for no, that is 1, 5, 6, 7, 8. Out of that, how many are yes? Only 1, and all the rest of them are no. So 80% no and 20% yes. So we have something that we don't want. Okay, so and it is not giving us an optimal decision about what, how to now split again, or should we stop here? So as here this right hand side has insurance as 1 yes and 4 no. So we need to do something. So what the something here? So let's see how to proceed next. Now we need to decide that as something, this portion here, this part here, if you see 100% yes we achieved and 0% no. So we just found a decision that if child child attribute value is yes, then we have to make a decision whatever comes next. The insurance value, if someone has a child, then he or she is likely supposed to have an insurance. They will pay for an insurance. And if they don't have a child, then they have to come through this part or the branch of the decision tree where it is uncertain that whether they can make a decision or not, because we have 20% yes and 80% no. In order to have a decision, we need to proceed again. And how to proceed? If you see how to proceed now, now we need to find out the information gain based on all the instances, that is 1, 5, 6, 7, 8, for which we have uncertainty. Hope you understood that. Okay. So for 1, 5, 6, 1, 5, 6, 7, 8, we need to find out the overall information gain. Okay. Sorry. I need to, this part I need to take up here. It was hiding that thing. So out of how many? 1, 2, 3, 4, 5. 1 is yes and 4 are no's. So for that, we calculate the info, that probability, which is 0.7. That is the overall entropy of the given data set. In the same way, find out first for the house. For house, we have 4 no's and 1 yes. Okay. So for T no, we need to see that out of Total 4 no's, we have 3 associated with no of the insurance and 1 associated with yes. That is how you calculate it. And T of yes, there is only one here. 1 yes is associated with insurance, 1 no. So we have this where the no probability is there for insurance. For yes probability, we don't have anything. So it will be 0. Then calculate the info, then the gain in the similar way, and we got this as the value for the attribute house. Okay. In the same way, we need to find out for car. Next step. So see here in the next step, this is the similar thing I have repeated, info T. And here if you see for car, we have 1 yes and 4 no's. Okay. So for yes, first for yes, let's see what do we have. 1 yes, 1 yes. So 1 1. For no, nothing is there, 0 0. For T no, all the no's are associated with all the no's of the insurance from the car. So 1 for 100% and no one of the instances of the car attribute associated with the yes. So it will be 0. Similarly, calculate the gain of the car, which is higher here in comparison to house. So what do? Now we need to decide that here we got as the information gain of the car attribute is higher. So now we need to decide that we have to split the child, that is no. Okay. And here it will be divided or split based on this criteria. See. Okay. See how it has been split here. Okay. So when we split the child equals to no node, we get the following branches with definite results. When car is yes, 100% someone is likely to get an insurance. Okay. And no, for no, that is 0%. In the same way, for 5 6 7 8, we have all 100%, so it will be 0% yes and 100% no. So here we can make a decision about how to um, infer something from the given node. If someone doesn't have a child but has a car, they are likely to buy an insurance. If someone has not don't have a child and don't have a car also, they are unlikely to buy an insurance. They're most likely not to buy an insurance. Okay. So this is our final decision tree where we can make a decision. So let's see an example based on this, whatever we have got, our decision tree. Okay. We need to find out for a new person. Suppose someone has a house, okay, has a car, but doesn't have a child. So we need to start at the root. Child, yes or no? So child is no. Okay. If child is no, then is your car yes? So car is yes. So that person is likely to buy an insurance. Correct. So this is how it will work in a decision tree. So based on the termination criteria, so where do you want to terminate? So when can you make a conclusion? The decision tree is final if a node has an optimal result with 100% yes or 0% no, and then either 100% as no and 0% as yes. Okay, this is how you can infer or make a conclusion about a decision tree. Next, we are going to see the difference between our ID3 and C4.5. Here, this is the main difference. The gain is calculated by this formula, and in the C4.5, we can consider everything is similar. Info T, info AT. AT is for a given particular attribute, and info T is for the whole overall data set. But there we have another one, split info. Okay, and this is something which is considered in case of C4.5. Okay, and for split info A, it is a little bit different for calculating. So this is how it will be calculated. We basically take the probabilities of all the attributes and then sum them together and take a negative sign of that. And we need to divide by overall info T and info AT. So let's see one example based on this formula. Mm, okay, I just made. So thoroughly, if you want to see the formula, how the split info for a given attribute um, is calculated. So this is how it will be calculated. The probability, we need to basically consider the probability of classification of an attribute or misclassification of an attribute. It will be more clear if we go through an example here. Okay. Again, we are taking the same example. So 50% yes, 50% no. We got info T as 1. For the given attribute house, how many of them are yes and how many of them are no's, and how many of them are associated with yes of insurance and no of insurance. So for every step by step, we will see the info or the entropy of the no first. So this is one no and here is one no. Okay. So total 40 no. How many no's? Out of 4 no's, we have 3 associated with no and 1 associated with yes. Then for yes, 1 yes associated with no, 3 yes associated with yes. So we calculated that. Okay, we calculated this. Next, we calculate the info of house 2, the entropy of this given attribute. We already saw this formula. Okay. Now the split info house, how would you calculate it? It's basically, we now pay attention to our house attribute only. Okay, so the split house will be how many yes are there in total whole attribute house, half, and how many are how many of them are no? 1, 2, 3, 4, same. So this is how the split info house is calculated for a given attribute house. Then for gain house, you basically have to take this formula. In the previous slide, you will find that formula, info of T minus info of given attribute, that is house, then the split info of house. You get this value and this is your overall gain. It is just in C4.5, it is done a little bit in a different way. We just have to consider split info. Instead, we don't use the split info in our ID3. That is the biggest difference. Same way we have for the car. For the car, again same half. So we have overall entropy as 1 here. For T, yes. How many yes? 100% yes, no. So for no, we have 6 no's. 2 of them associated with yes and 4 of them associated with no. So for T yes, we have 1 log 1, 0 log 0. For T no, we have 2 divided by 6, that will be your 1 divided by 3, which is associated with yes, and how many? 4 no's. 4 no's out of total 6 associated with no. If you again simplify, it will be 2 divided by 3. So this is being written over here. Okay, and you got info of T no. Next, in the same way, info or the entropy of the given attribute car is determined. Then split info is determined how? Out of total 8 instances, how many of them are yes? 2 by 8. And how many of them are no? 6 by 8. We just basically use that in our split info. After you get this, you calculate the gain value. Okay. In the same way, you should be able to calculate for the attribute child. Try to practice this yourself. Try to find out the gain of the child. Okay. And so after you find out, then you see that how do you proceed with the splitting of the tree based on which attributes gain value, whether it is house, whether it is car, or whether it is child. Okay. So this was your C 4.5. Next, let's see another one, major or a matrix. So ID3, and there is another one, CART algorithm, which were invented independently. It's basically for decision tree. Okay, independently, and both of the algorithm follow the similar approach of learning decision tree from training example. So there are various matrix of decision tree. So algorithms of constructing the decision tree usually work top down approach by choosing a variable at each step that best splits the set of items. Okay, and to determine the best, actually there are different criterias. So what are those criterias? There is a Guinea index, which is also called Guinea impurity. So which is a measure of how often a randomly chosen element from the given item set or a set would be incorrectly labeled if it was randomly labeled according to the overall distribution of labels in the data set. Okay. So this Guinea impurity can be computed by summing or adding all the probability of an item with label being chosen at times the probability of by a mistake or doing a misclassification of a given item. So if we have a data set D and it has n number of classes, then the Guinea impurity will be calculated in this way. The probabilities of all the classes 1 up to n, they will be added together. Then you make a subtraction from 1 of the whole summation of all the probabilities. Pj is considered as the individual frequency or probability of all given classes. But if the data set is split on an attribute into two subsets D1, D2, then this is the formula how you calculate it. Guinea on for a specific attribute. Then how do you define how to lower the impurity or reduce the impurity? It will be basically your overall Guinea of the given data set minus the given whole data set minus a particular data set. Okay. And your Guinea impurity reaches its minimum or zero when all the cases in the node in a decision tree fall into a single target category. Let's see what is the main difference here and how is it calculated. So based on this formula, Guinea D 1 minus summation of Pj, this is our main difference for the calculating the entropy of the given data set. So let's see an example. So here we are taking again same example, okay? 50% yes, 50% no. But based on our formula, what it will be? It will be 1 minus summation of individual classes probabilities, okay? So this is the main difference in between the other algorithm and in terms of this Guinea index for calculating the entropy. Now for calculating the house, what we have total how many yes? 4 yes, this one and this one. So where 100% of them is associated with yes, probability of incidence, and one of them is no. So we have 3 by 4, 1 by 4. 3 by 4, 1 by 4. This is for yes. So it will be again subtracted from overall 1. We have this. Now T of no is calculated in the same way. 3 no's, only 1 no associated with 1 yes. So that's what we have here. Info of house 2 will be calculated in similar way. Info of T no. How many no's are there? Total 4. 4 divided by all the instances 8. So it will be 1 by 2. Yes is also same. 4 divided by 8 of TS will be 0.375. And how do you find the gain? It's basically the same formula. Info of overall entropy of the whole data set minus a given attribute's entropy that we found. And this is the final gain on the attribute house. In the similar way, we will calculate for attribute car. You already know this, right? Just refer to all the formulas and see how many car has yes as label and how many of them are no. And first calculate the overall data set based on the label that you want to classify, that is insurance. First, that will be your info T. Then for car, first calculate the info T of yes, then T of no, then calculate the info of car with respect to the given data set. That is your info of car T. And lastly, gain of car T will be the overall info T minus your overall info. Oh, sorry. It by mistake I have written house. It should be car. Okay, info of car T that you found here. And these are the two values. Okay. Next, you try to find out what is the gain based on this attribute, that is child T here. Then you need to make the decision and just follow the first example how we formed a decision tree and see what will be the splitting criteria based on the highest information gain of the three attributes. Next, just to give a conclusion. Okay, we are done with all the basic algorithms and you will have an assignment related to it as well, mostly the entropy and different indexes of the entropy that or measures that we covered so far. So there are actually three measures that we learned here: the information gain, okay, and okay, information gain, the gain ratio and Guinea index, but they are always helpful. But based on certain conclusions, sometimes your inference, whatever you would like to find out, your accuracy may differ. So information gain for IDE3, it's mostly based for IDE3 algorithm biased towards the multi-valued attributes. Actually, for multi-valued attributes, it will give you more accuracy in terms of other attributes such as continuous or nominal. And there are certain something different for the gain ratio for C4.5, where it always tend to prefer the unbalanced split. Sometimes the splits are not balanced or proper. Okay. In the same way, Guinea index is also biased towards multi-valued attributes. And if there are a number of classes, if we have a vast or large number of classes, then there is a difficulty of doing the classification. And sometimes we may not get a proper output or our classification result. Okay, so this is all that we have in this chapter. Please go through go through your book and see if there are any examples which will be helpful to do the uh, assignment as well. Let me make an announcement for the assignment here. After this chapter 3 classification, you will have this assignment 3. There is a document attached. You can open it and read it thoroughly how to solve the questions. The instructions are given to you. So try to submit the PDF document, okay? After you create your document using a Word file, so try to convert it to PDF. And there are two problems basically. One of them is related to support vector machine, and the next one is for our decision tree. So the support vector machine here, it says it's basically, if you remember, we did a problem for the support vector machine. We had a set of points. Then for given two new points, how do you define where those points will lie, whether in the positive side or in the negative side of the hyperplane? That you need to make this decide here. This is your given data set here, this one, and two new points are given. You need to find the decision boundary and you need to show me the detailed calculation process. If you don't see the detailed calculation, then your points will be deducted. Then don't just leave the answer. Try to solve it properly and show me step by step. Then use that decision boundary to classify the testing data. These 2 points, eighth and ninth point. That is your support vector machine. And here, this problem, this is your given data set. There are two attributes. This is actually a decision tree. Two attributes, and these are your class labels. Two labels are there, either plus or minus, like your yes or no in the problem that we were going through today. So first, you need to show me the information gain while making a splitting condition on A and B. And you need to show which attribute you will actually choose for the decision tree induction. Okay. So which attribute you should choose based on the information gain for splitting condition of the decision tree. And it will be better if you show the decision tree as well. After you split the A and B, you need to calculate the gain in the Guinea Index, and then you also have to show which attribute of the decision tree induction algorithm you will choose that in that case. Information gain and Guinea Index. Just refer to the slides and see what formulas are being used in those examples and try to apply the formula, correct formula for both the cases. Do you have any question? Okay, I'm just stopping the recording now. After this, we can discuss if you have any questions.